enthalpy values are provided below. We've got reaction of hydrogen gas plus iodine gas to give you hydrogen iodide. The enthalpy of reaction is minus 9 kilojoule per mole. Minus indicate exothermic. So this is what's happened. You've got hydrogen gas plus iodine gas to give you hydrogen iodide gas. The hydrogen itself is one H bonded to another H plus iodine bonded to another iodine to then give you 2 mole of hydrogen and iodine. Now these two here is what we called fission, or you might call it endothermic or bond breaking. So this is bond breaking because you have to break that bond. And we call that fission, endothermic, or bond breaking. On this side, we've got fusion, exothermic, and bond making. Right, bond breaking are always positive because you want to break the bond, you put energy into it. And bond making are always negative. So what we've got now is we've got this question is asking us to what is the bond enthalpy for hydrogen iodide. We don't know what bond enthalpy is. We've got 1 H bond we need to break, plus we need to break I and I bond, and so that will be positive. So we got the positive values here, they'll be positive. But this making one is always going to be negative. So, but we're making 2 of those, so we're making HI and HI. We don't know what they are, so we can call it X and X. So if we add these 2 bonds together, this one will be plus 4, 3, 6. Why are they plus? Because you're breaking them. And then plus for this one is 1, 5, 1. This one, you're not breaking them, you're making them, so there will be minus 2x. And that will be equal to the overall reaction, which is minus 9. So that's how you do the equation for that. You add up the positive, the bond breaking one, reactant is always bond breaking, and product is always bond making. So for the reactant, when you add them together, you're going to get 5, 8, 7, and that's positive. And this one is minus 2x, and that equals minus 9. So if I solve it here, which means that I have now got to take minus 9 to the other side and bring 2x to outside. So I'm going to get 5, 8, 7 plus 9 equals 2x. So if I add 9 to that, it's like adding 10 to it. So that'll be 5. It should be 9, 7, but you take 1 away. So that's 5, 9, 6. It will be equal to 2x. Divide both sides by 2, should be 596 over 2 will be equal to x. That implies that x will be 298. So we're looking for 298. Is it going to be negative or positive? It's going to be negative. It's going to be, we're looking for the energy values to break it, because so it's going to be positive. Even though we're making it, we present it in a positive way because these are the bond enthalpy. Bond enthalpy is always in positive, right? Because bond enthalpy is saying the energy required to break that bond. So it's not going to, we know when you're making it, it's negative, but when you're breaking it, it'll be positive. So therefore, the 298 kilojoules per mole will be positive. So because they said bond enthalpy, so it can be C, and that'll be C.